Hello, everyone. My name is Xinhui, and I'm a PhD candidate from University of Michigan, Ann Arbor. It is my great pleasure to present work collaborating with my colleagues Shriti Raj, Bingjin Huang, Professor Songyang Park, and Mark Newman on exploring different smartwatch interfaces for lightweight in situ self-reporting. In-situ self-reporting is an important component in research studies to collect data about participants' subjective experience, such as symptom perception and mood. With smartwatches, participants have easier access to self-report systems and can contribute data anytime, anywhere with less recalling bias. However, frequent self-reports are often burdensome because participants need to make a response in dynamic context. Research shows that single-item self-reporting for smartwatches helps reduce user burden. For example, participants answer a question with glances and a simple tap on the screen. However, we do not know if basic input methods are still useful under various life scenarios. Also, it is a central challenge to make an input on the small touchscreen. Hence, we are motivated to explore if there are alternative input techniques that make self-reporting less burdensome. We ask the following question: how is the user experience of self-reporting affected by different types of interface designs across a variety of contexts? To answer this question, we first identified input gestures, input continuity, and option layouts as key dimensions and proposed 8 design props varying in these dimensions. To answer a rating scale question, users either perform a continuous gesture or select a response through multiple repetitive inputs. We refer to this attribute as input continuity. We also consider different option layouts, varying from displaying one single option using card layout or multiple options in a hierarchical layout. For more details about design props, please refer to our paper. In-situ self-reporting in general takes only seconds to complete. This suggests that more nuances in user experience may be seen from a qualitative perspective by understanding participants' perception toward different interface designs. As an initial step, we conducted an in-lab user study with 24 participants. Participants used 3 randomly selected interfaces and the 3 simulated scenarios: gaming, walking, and social chatting. These scenarios varied in one's physical or cognitive attention available for the self-report task. After each self-report task, we held mini interviews to probe users' reactions to different interface designs. Overall, we found that there is not a one-size-fits-all interface designs across different contexts. Participants' mobility, cognitive engagement, and hand occupation interact with option layouts and gestures to affect participants' preference. The perceived precedence of these factors vary with context, and therefore participants show a changing attitude toward a single interface. For example, typing techniques were simple in general, but without more difficult than drawing numbers when talking to another person due to the social appropriateness. In particular, participants reacted more positively towards continuous gestures when they were more sedentary. On the contrary, in mobile situations, participants prefer to use discrete input gestures because they have less requirement on precision. Meanwhile, we observed 2 strategies that participants actively developed to reduce perceived demand. These include microscheduling and adopt eyes-free interaction. With microscheduling, some participants arranged the one of 2 moments or several moments for a self-report task. For example, the hierarchical layout allowed participants to catch up with main activities between the first and second level of option selection. Also, after some practice, participants could leverage the physical frame of smartwatch to locate options or count the number of gesture inputs to select a numerical response without looking at the screen. These strategies help participants better fit a self-report task into main activities. We discussed the implication for future design. The first is to consider the context of use when designing self-report interfaces. One way is to prioritize interface designs for key sampling contexts. If the self-report measure is frequently delivered in stable condition, Designers may consider continuous gestures that also enable eyes-free interaction to minimize the disruption. Also, there might be an opportunity to adopt a pair of complementary input gestures on one single layout to cover different contexts. The observation of user strategies implies that self-report interface designs should go beyond the requirement of simple and brief interactions. Designers may think how to support design users' strategies like micro-scheduling and support eyes-free interaction. For more details, please refer to our paper. This brings to the end of our talk. I would like to thank my advisors, Mark Newman and Song-Young Park, and the great research team to make this happen. Thank you very much for listening to my talk, and I'm happy to take any questions.